Good morning and welcome to our sixth and final webinar in the Life Course Visual Toolkit series. The webinar is focused on the integration of complexity science and life course research. We have covered topics that include data integration, exposomics, complex methods, translating findings to inform the public and policymakers, and new approaches to intervention. We are very excited for the final webinar, which will walk us through analytical methods that can capture the multiple dimensions of time. Understanding how health develops over time is central to life course research, and we are excited to have Dr. Kristin Palmsten and Dr. Gretchen Bandoli tell us about some of the exciting work they have been doing in this area. Their collaborative projects have investigated the effects of medication use during pregnancy using multiple large longitudinal data sets. Dr. Kristin Palmsten is an investigator in the research division of the HealthPartners Institute. Her research areas of interest include perinatal epidemiology, pharmacoepidemiology, causal inference, and medication use and safety during pregnancy. Thank you, Dr. Palmsten.
Great. Thank you so much, Heidi, and thank you very much to the committee for inviting me to speak today. The title of my talk is Longitudinal Trajectories, Letting the Data Show Us. So I'm going to be providing some motivating background and an introduction to longitudinal cluster analysis, as well as a very brief methods overview, and then I'll hand it off to Dr. Bandoli to provide some more in-depth motivating examples from the field of perinatal epidemiology. So health researchers are familiar with the challenge of high density data. We have to deal with multiple variables that often have multiple dimensions, and the variables are collected on many participants, and then longitudinal measurements are made across space, time, and perhaps across generations. So this can be really overwhelming for researchers and trying to figure out how to handle all these data points. So I'll give an example from my field of pharmacoepidemiology. Pharmacoepidemiologists often have to work with pharmacy claims data, and these are really high dimensional dense data. So we have data on a whole array of medications, and each medication has important dimensions to consider, including dose, duration, and adherence. And we have observations on tens of thousands of patients in these claims databases. And there are longitudinal measurements for individuals over time in the scale of years, or maybe even decades. There are dispensing dates that can happen at least once a month, if not more frequently, and then information on days supply associated with each dispensing date. So we really have a lot of dimensions of data to consider when using pharmacy claims data, and I know that's true in other substance areas as well. And now I just want to drive down on that point a little bit more and give a sub-example of medication exposure during pregnancy. So this is a hypothetical example, and we have 5 different women, and their medication exposures according to pregnancy and gestational week of pregnancy are plotted here. And we have a heat map of the dose for each gestational week, with the heat map legend in the color above, with yellow indicating smaller, lower doses, and the red indicating higher doses. And this is all, we're talking about cumulative dose here. So you can see that all these women are exposed during pregnancy, and they're actually all exposed within each trimester of pregnancy, and they all have the same total cumulative exposure of medication. But there's a lot of variability across women. So one woman is taking low doses throughout the entire pregnancy, and some women are taking sporadic high doses just at a few short time points during pregnancy. So we have a lot of medication exposure information just across these 5 women. Now, a standard approach might oversimplify the data and just fold all these women, collapse them into one exposure level. So oftentimes in the standard approach might be to classify any medication exposure during pregnancy at one level and then no exposure at another level, or to consider any medication exposure in each trimester, or to even consider total cumulative dose during pregnancy. But with all these approaches, these standard approaches, all these women would be classified in the same exposure level. And that really removes some important variability. So that would remove timing of initiation, discontinuation, coverage gaps, average dose, dose changes, cumulative dose changes that could be important when studying perinatal outcomes. So how can we preserve some of this complexity, but simplify so that we're not overwhelmed with high dimensional data? And my solution that I've been working on over the past few years is doing longitudinal cluster analysis. And this approach groups individuals with similar patterns of values for a given variable or variables measured at multiple time points or multiple points. And the objective of longitudinal cluster analysis is to create homogeneous groups that minimize within group variation but maximize between group variation. And these approaches have been used in many substantive areas. And this is just a hypothetical figure of a longitudinal cluster analysis. This is from Kmeans Longitudinal, which I'll be describing in more depth later. But this is just showing Black individual trajectories of exposure over time. And then the cluster analysis has identified average trajectory groups into which these individual trajectories are clustered. So then overall patterns can be seen in the data over time. So longitudinal trajectories can be used in many different ways in research. They can be used to visualize and understand real-world patterns of data. And a published example of this is utilization of opioids following cesarean delivery. Trajectories can be used to model exposures and exposure outcome associations, such as trajectories of breastfeeding, linked with childhood obesity. And trajectories can be used to model outcomes and exposure outcome associations. And a published example of this is parental education and trajectories of childhood physical aggression. Importantly, trajectories can also be used as covariates to adjust for confounding. And in my work, I've used oral corticosteroid dose trajectories as a proxy for lupus disease severity. We can also use joint or multi-trajectory modeling when we have more than one correlated or theoretically related variables. And trajectories can be modeled across multiple variables. And this is just an example, a hypothetical example from Kmeans Longitudinal, where there's the same trajectory groups, but plotted for 3 related variables. So some examples of joint trajectories are childhood body mass index and physical activity, medication dose and disease severity trajectories can be jointly modeled. Maternal and paternal depression screening scores could be modeled throughout the postpartum period. And you could even imagine an intergenerational joint trajectory of a maternal and offspring exposure, for example, like tobacco use. Longitudinal cluster analysis, one really beneficial part is that they can be quite flexible and they can accommodate our whole range of applications. So they've been used to look at trajectories throughout pregnancy, before pregnancy, during pregnancy, and in the postpartum period. They've been used to study childhood developmental outcomes and can be used in life course and intergenerational research. They've been used to describe trajectories of symptoms, severity, adherence, dose, and duration and intensity. And they have been used to describe both acute and chronic exposures. And the timescale is very flexible. Trajectories have been used to, over the course of days, weeks, months, and years, to model various exposures and outcomes and covariates. So I want to give a very brief methods overview. There are several methods that can be used to conduct longitudinal cluster analysis, and I'm going to be sharing a few of them today. I wanted to talk about unsupervised methods. So there are no a priori assumptions about group membership with respect to other study variables like exposures or outcomes. That's what I mean when I say unsupervised. I mean, we don't make any group assignments based on an exposure or outcome, for example, or other variables in the study. And I'm going to briefly highlight some of the methods that an investigator could choose from today. So Kmeans Longitudinal is a non-parametric clustering method, and the approach creates clusters and then calculates the mean trajectory within each cluster. And basically the algorithm tries to minimize the distance between an individual's mean observation and then the trajectory group mean, and then assigns individuals into clusters in which that distance can be minimized. So these 3 steps are repeated iteratively until there are no more changes in cluster assignments. And there's a really nice R package called KML that can be used to do this. There are quality criteria that can help select the optimal number of clusters, but one drawback is that the solutions do not always converge. In fact, when I've used this approach, they usually don't converge. And so we'll talk about that later as a limitation. But I just have an example of what this KML looks like in the literature. So this is an example of during pregnancy of exposure to psychotropic medications. And you can see different individual trajectories in the thin lines and then grouped trajectories in the thicker lines, representing the average dose across pregnancy months. Moving on to group-based trajectory models. In this approach, analysts specify polynomial shapes of trajectories and the number of possible groups. And these methods simultaneously estimate a multinomial model for group assignment probabilities, and then models estimating longitudinal trajectories using polynomial functions of time, like a cubic function, for example. And then individuals are assigned to the trajectory group in which they had the highest membership probability. And this can be implemented with PROC, Traj, and SAS. And Bayesian information criteria are used to help select the optimal number of groups. And I just have examples from the literature here. This group-based trajectory models have been used a fair amount now in pharmacoepidemiology to study adherence to medications over time. So trying to separate different patterns of individuals' adherence over time to a whole variety of different medications. And then I'll just briefly mention hierarchical clustering analysis. This is an approach based on a custom distance measure. And what's unique about this is this approach can allow for categorical variables to be plotted in trajectories over time. And the user specifies the similarity measure. And an example of this would be a mechanism of action for studying medications. And then the hierarchy of clusters can be visualized through a dendrogram. And there's an example here with a reference to that in the literature. And then just to touch on a couple more methods, there's latent class analysis as well, and latent class growth mixture modeling, which is similar to group-based trajectory models, but then actually allows for variations in individual trajectories within the same trajectory group. And I just want to briefly touch on some of the concerns when using trajectory analysis. Unfortunately, this doesn't give us a pass on all the typical concerns that we usually have about bias. So measurement error can be a concern, and it could change trajectory shape and group membership from what it would have been without error. Confounding and time varying confounding can be a really big concern. And an example of this is medication dose trajectories being confounded by disease severity. As you could imagine, that changes in medication dose would be caused by changes in disease severity, which could also be related to an outcome under study. And then generalizability of observed trajectories to other populations can also be a concern if you're running these models in a specific population. It's always a question of who will these trajectories generalize to? And then some other considerations for investigators. There are several different approaches to clustering analysis that I have presented today, and I haven't even covered all of them. So investigators would have to pick one or a few in order to do a study. So the best clustering method really depends, I think, on the study question and available data. And I think that's an area of research to help that's needed to help investigators really understand which approach would be best suited for their study question and their data. The selection of cluster number can be subjective, and I did mention some selection criteria when I was giving the brief overview of the methods. But when it comes down to it, clinical relevance of clusters, trajectory shapes, and sample size are also really important considerations. If we run a trajectory analysis and only find a group of 5 individuals out of 5,000, that trajectory group might not really be clinically relevant. And then within cluster heterogeneity can be a concern. If there's a lot of noise, we might miss a signal. So we know that there's going to be heterogeneity within each trajectory, but we just want to make sure it's not so noisy that it's no longer useful. And then just to keep in mind, missing data methods are not necessarily appropriate. Some of these approaches need the same number of days of observation in order to run. Otherwise, missing data methods are implemented, but this may not always work out. An example of this is that it might not make sense to necessarily impute medication dose after delivery for those with shorter gestations when trying to study prenatal medication exposure. So if we're trying to study the time during pregnancy and women have varying gestational lengths, then it might not make sense, it wouldn't make sense to try to impute data after the time of delivery in order for everyone to have the same period of observation. So just caution when implementing automatic missing data methods, approaches that are sometimes implemented in these cluster analysis packages, software packages. So in summary, longitudinal cluster analysis can help us identify and group individuals with similar trajectories over time. They can help us visualize trajectories, which I think is really important and can be really useful for understanding data and generating hypotheses. And these cluster analysis can simplify high density data while preserving potentially important complexity when trying to study an exposure outcome association. There are several different approaches that investigators will have to consider when conducting a longitudinal cluster analysis. And it's important for investigators to remember that all the biases are still at play and to consider the impact of various biases on the trajectories. And with that, I'd like to wrap up and then pass it over to Dr. Bandoli, who will be providing more in-depth examples of longitudinal cluster analysis from the field of perinatal epidemiology. Thanks for your attention.
Thank you. So we have time for a couple quick questions before we switch over. So the first one we had was, do you have any suggestions for new investigators interested in longitudinal cluster analyses? And are there any things you wish you knew from when you started this work?
Well, I think if you can take any sort of some time, I would say, to play around with the software packages if you have some data and just get a feeling for them. I think once you try some of the methods, then an individual could implement them quite quickly. So I think just playing around with the data, playing around with the software packages, and then reading some key references. And I did include those in my slides, the ones that I thought were important and helpful for explaining exactly what those software packages are doing and what are those distance measures. And so I think diving into the literature a little bit and then spending some time playing around with the various software packages can be useful.
Perfect, thank you. The next question we had was, can you give a sense of what the sample size should be for these methods?
Yes, and Gretchen might want to weigh in on this as well. I think overall, it probably depends a little bit on your study question and how variable you think the variable that you are studying is. And I think that once we get into smaller numbers, if we have cluster sizes that are getting into just 5 individuals per cluster, that might not necessarily be clinically relevant. So having a large enough sample size. And I think usually we try to stick with, in terms of cluster size, at least 5% of the sample size within a cluster and no smaller. So that you can kind of think about like what target size you want your clusters to be, and then the variability in your data to help determine the sample size. And Gretchen and I have, I think, Dr. Bandoli and I have used these approaches on sample sizes of around 200 or more individuals with a particular variable that we're studying, a particular exposure that we're studying.
Thank you. So the next question was, could you explain a little bit how latent class analysis differs from the other trajectory approaches and what allows for the most nuance and consideration for polynomial trajectories?
Yeah, so for the first part, the latent class analysis, it's similar to group-based trajectory methods, but uses a different framework, a structural equation modeling framework, and I actually haven't applied those methods. And then what was the question about the polynomial? Sorry, the shapes?
Yeah, sorry, I moved it. So what allows for the most nuance and consideration for polynomial trajectories?
Well, I think specifying the whole range of polynomial trajectories in ProcTraj, I think you can specify up to the 4th order of polynomials. So I think I would suggest allowing the option to run with the whole wide range of the different orders of polynomials, and then letting the cluster results come in and then taking a look at it. So I think as an analyst, I would probably just specify an entire range as opposed to picking one, unless I felt that I already had a good idea of the shape that a trajectory made over time.
Thank you. And I think we have time for one last question. So how do you typically deal with missing data in these methods, if at all?
Oh, this is a great question. So the approach that I've been using is to actually, I should back up and saying I've been applying these only during pregnancy, and pregnancy is something that, of course, there's different gestational lengths for each individual. And in order to get these methods to run, and like group-based trajectory models or Kmeans Longitudinal, will have to have the same number of observational units, so the same number of days, for example, or same number of weeks. So in order to get the methods to run, I've limited the sample to those who, say, for example, deliver after 32 gestational weeks or after 36 gestational weeks, in order to get the models to run and not have to impute exposure days after delivery. That said, I've usually taken a few different cut points in order to do a sensitivity analyses, so that I understand like who exactly are we dropping out when we implement these different trajectories, and do they greatly change the shapes. And so far, my experience, it hasn't. Usually we're dropping out a small number, a small proportion of the individuals. So usually it doesn't have a big impact on trajectory shapes.
Thank you. And
I have one more thing. We treat it sort of as a landmark analysis would be another way to think about it.
Perfect. Sorry about that. So next question would be, in your opinion, would the different methods give roughly the same answer from the same data?
Yeah, I think this is a really great question. I haven't done any multiple method comparison. I know in the literature there have been some comparisons between a standard approach of sort of just a dichotomous exposure versus a longitudinal trajectory exposures, and some analyses have shown that trajectories have identified exposure outcome associations using with the trajectories, but not with a standardized dichotomous approach. But I can't speak to whether you get different answers with different approaches. And I think that's really an area that needs more exploration now that all these software packages are becoming pretty easily available and or free and easy to implement.
And there was one paper actually done where they ran both ProcTraj and KML in the same data set, and they actually did result in the same, essentially same cluster shape, same number of trajectories. If I have time at the end, I can find the reference and put it into the chat for that, but I know it has been done once.
Yes, that is the TWISC paper. Thanks for reminding me about that, Gretchen. The TWISC paper does, I have a reference to that in one of my slides. Let's see if I can pull it up. But that's, yeah, that was a nice comparison. And they actually go through, I think, 4 of the 5 methods that I presented today. So thank you for reminding me about that.
There it is.
Let's see. Okay, I'm not seeing it, sorry.
I think you passed it at one point. I saw it come up briefly.
Okay, classifying developmental trajectories over time should be done with great caution, a comparison between methods. The Journal of Clinical Epidemiology.
Thank you. Would you mind dropping that reference in the chat after your presentation?
Certainly.
All right. Well, thank you very much, Dr. Palmsten. I don't know if you or Dr. Bandoli have any other additional comments to make about the questions that have been asked so far.
I saw a few of them, and I'll try to make sure that I'm answering those as I go through my examples as well.
Thank you. And Dr. Palmsten, feel free to answer some of these in the chat as Dr. Bandoli is talking, if you would like to. It's great to have both of your input and great to have 2 experts on the same area on the same call. So thank you again for your presentation. It was fantastic. We're going to go ahead and move to Dr. Bandoli now. So Dr. Gretchen Bandoli is an assistant professor of pediatrics at the University of California, San Diego. And she's also been a member of the planning committee for this webinar series. So we would like to thank her for her input. And she has a special interest in the expansion of methodologies to characterize complex exposures during pregnancy, including alcohol, cannabis, and medications. So Dr. Bandoli, we're going to go ahead and turn it over to you. Thank you.
Great. Well, thank you. So Dr. Palmsten gave us a really nice overview of different examples of ways to deal with data across time. And I'm now going to give a few examples of longitudinal cluster analysis, primarily focusing on KML, but we'll also look at one example of group-based trajectory methods through ProcTraj. And these are all examples from perinatal epidemiology. So the reason why Dr. Palmsten and I really started kind of getting into looking at different ways to classify exposures over gestation is, even though when you think about the course of a lifespan, the time in utero was such a short amount of time, but those roughly 40 weeks in gestation are highly dynamic with huge changes happening daily, weekly across gestation. And so depending on what outcome you're interested in, your exposure window may be very, very narrow. When we think about things like major structural malformations, the first 12 weeks are critical, but even within those malformations, we know that different weeks will close that critical window for when the structure has finished development and someone is no longer at risk to, for example, a teratogen of interest. However, outside of structural malformations, there are also other time-related factors that we need to think about when we're looking at different exposures across gestation. And importantly, we often don't know when the sensitive periods are, or kind of when the periods of relevance are to the outcome that we're looking at. And so that's why we started looking for different methods that would be more precise in being able to show us the timing, the intensity, and the duration of exposure over gestation. And it's not only the changes that are happening to the fetus. Pregnancy is also a highly dynamic time for the mother as well. Her behavior may change from her previous behaviors before she recognized that she was pregnant, and those behaviors may continue to change across gestation. specifically the management of medications and other exposures is also highly variable. And this is something that Dr. Palmsten and I have been looking into a lot, because often when a mother finds out that she's pregnant, she may choose to discontinue either a medication or an exposure that she's been taking. She may substitute something else. And then later in gestation, she may actually resume or change the dose, either due to fear of complications with the pregnancy, or because of the physiologic changes in pregnancy to the woman necessitating a change in dose. So these issues are compounded by the fact that we have potentially short etiologically relevant windows. And as I mentioned earlier, we often don't understand those windows. It's challenging to estimate the timing of gestation, and there's also tremendous variability in the timing of recognition of pregnancy. So we know that often a lot of changes happen around when a woman recognizes that she's pregnant, but that timing of when that pregnancy recognition occurs is also highly variable from pregnancy to pregnancy, resulting in a lot of behavioral changes that kind of can span across multiple weeks or months of gestation when you're looking across a group of pregnancies. So I'm going to go through 3 specific examples of using longitudinal cluster analysis in pregnancy, and we're going to start by talking about alcohol exposure in utero. So this is some work that we did, and the kind of motivation for this work was, again, historically, we've tended to classify things like alcohol as a dichotomous variable, whether someone drank. We may look at within each trimester, was someone drinking, yes, no. Sometimes we would use a cumulative dose across gestation, but like Dr. Palmsten showed in that heat map, you can get to the same cumulative dose in very, very different ways across gestation. And alcohol is one of those exposures that we often see overlapping with a pregnancy before the recognition of pregnancy, then dropping off fairly quickly upon pregnancy recognition in some, not all pregnancies. And then sometimes towards the 2nd or 3rd trimester, you may actually see a resumption of alcohol consumption. And so we wanted an exposure variable that was flexible to those different scenarios. One of the kind of upfront things that you have to do when you want to do longitudinal cluster analysis is getting everyone on the same time scale. And so you need a data set that has at least 2 time points. Otherwise, there's really no need to do trajectories. And then you need to kind of get it into almost a calendar form where everyone has a day 0 through a day, whatever you're looking at. So here we had a cohort of over 700 women who were enrolled in a prospective study based upon their alcohol use around the time of conception. And here we had reports from the visit 1 that happened sometime in the 1st or 2nd trimester of what the mother was drinking around the time of conception, when she actually recognized pregnancy. And then we had a report from the what she was currently drinking in that first visit 1. And then we also had a visit 2. And so from that, where she updated her alcohol exposure information. So from that, we could essentially make a calendar where we took the visit 1 current drinking information and pushed that back to the time of recognition of pregnancy. She had told us how much she was drinking around conception, and so we could then push that forward to the time of recognition. And then we updated that information with the 2nd pregnancy interview to tell us if alcohol consumption had changed. From there, that got everyone into kind of a standard calendar of the average drinks per day. And we then grouped those into weeks and performed longitudinal cluster analysis. This was done in R with KML. Some of the questions were asked about how you choose a number of trajectories. And as Dr. Palmsten mentioned, there's really kind of no right answer. What we were looking for was to have enough people in the trajectories that we could do multivariable analysis. If you end up having, and you can think about that in the same way you would have your own exposure categories for any variable. But if you end up having to collapse down over a bunch of trajectories, you're kind of losing the benefit of doing those trajectories to begin with. But so out of ours, we had these 5 trajectories. And the way we kind of describe these are the women who had low or no use of alcohol in pregnancy. The women who started, these are absolute ounces per day, which 1 absolute ounce is equivalent to about 2 drinks. So here at 0.5, these are women who start having about a drink a day. And we had these divergence of trajectories where some women continued that in this low sustained group in blue, whereas some women had a pretty rapid discontinuation there in the low to moderate with reduction. We then had this moderate to high group who reduced alcohol early in pregnancy, and then this high, somewhat sustained group across gestation. And so when we look at the trajectories, what we were really interested in was particularly trying to exploit these two trajectories in the blue, which was the sustained trajectory, and the red that started off much higher, but dropped off. And so what you see is interesting is that we end up with this cross in the second trimester. So even though in the first trimester, this group in red actually had a lot more alcohol exposure to the offspring than the group in blue, once you get into the second trimester, we have a cross here where the fetus is now exposed to a higher level if they're in that blue trajectory than in the red. And you can see that here with the means that even though the overall pregnancy mean was essentially the same between the C and D trajectories, that while C started off lower at 0.42 versus a 0.62, they then crossed in the second trimester and then ended up at essentially the same place in the third trimester. And so we then took this and looked at our outcomes of interest. So we first looked at infant size at birth, looking at the weight, length, and head circumference. And what you see is that this group in blue, recall these are the ones who had more sustained, lower but sustained exposure, actually had lower weight and length at birth compared to the group in red, who started off with a higher exposure but then dropped off earlier. These confidence intervals completely overlap. It was just interesting to see the different point estimates there between the two trajectories. We also looked at neurodevelopmental outcomes. This was measured with the Bayley at both 6 months here on the mental and psychomotor developmental indices, as well as at 12 months. And we saw this same thing that not in the mental development, but in all of the other scales at both 6 months and 12 months, this group who had that lower but sustained exposure tended to have slightly worse outcomes compared to the group who had the higher exposure with earlier pregnancy reduction. So we were interested in how would this look if we had just done a traditional analysis? So if we hadn't teased out that kind of nuance of the two exposures, would we still have been able to see this? So we just did a traditional exposure analysis where we took the cumulative dose over pregnancy and divided it up into no use, light use, which was less than 1.5 drinks per week, moderate use, and heavy use, and then reran these analyses. And this is how we kind of would have typically done an analysis like this. And what you can see when we compare it to the trajectories is that we still, in that kind of low group in green, which matches our low group up here, you still see essentially the same thing, that there's really no change in any of the Bayley scales. You still see that in that highest trajectory in blue, that maps on really well to the high use here. But what we lose is that nuance between the two groups where you had the continued low exposure and the high exposure that dropped off. Those, if we had done a traditional analysis, will just get collapsed into the same estimate. And so you'll essentially just collapse over those, losing that nuance of how different patterns and the timing of change of alcohol can affect the outcomes. And so another group has actually done very similar work to this in a completely different data set. This came out of the Safe Passage study looking at drinks per drinking day of alcohol across gestation. And this group used the group-based trajectory modeling, the parametric approach that's available in SAS, as opposed to our non-parametric approach that was that we used in R. And what was really interesting is that when you compare the trajectories that we had to the trajectories that they did, there was actually a lot of similarity between these. So again, these are different data sets, but their parametric approach also found this low trajectory. They found kind of a moderate trajectory that sustained use. They had these two moderate and high discontinuing trajectories, and then more of a high, somewhat sustained trajectory. So it was really interesting seeing that in a completely different data set with a different longitudinal modeling approach, we really saw very similar patterns of use emerge. And this group has not published on their neurodevelopmental outcomes, but it'll be really interesting to see if they see some of those same things there between these crossing curves on differential risk estimates with their outcomes of interest. So that was alcohol, and I've kind of explained why we were interested in exposures to alcohol. We also were interested in doing this same approach with antidepressants and pregnancy. And the motivation there was that we tend to think of antidepressants as a binary exposure. Either you're taking them or you're not during gestation. But we know that that's not true. We know anecdotally that women will come off of their antidepressants because they're worried about the effects in pregnancy. women may actually start taking antidepressants later in gestation, or there may be dose changes. And so we were interested in seeing whether we could apply that same methodology to antidepressants across gestation. So here we used data from an administrative claims data set, Optum Labs data warehouse. And after we sampled the women with live-born infants and applied continuous enrollment around those, we ended up with a sample of 227,000 deliveries, which we were really excited to get to do trajectories in there because this was a much, much larger data set than we had previously gotten to use. So when we did the trajectories on antidepressant use, what we see, so we've modeled these twice. We were interested in malformations. As I previously said, those really have a critical period of the first 12 weeks. So we looked at antidepressant exposure here in the top panel just through 12 weeks of gestation. And then at the bottom, we ran it out through 35 weeks. What Dr. Palmsten was saying about you'll have missing data essentially if a woman delivers at earlier than another woman. What we did is we had all pregnancies ending at 35 weeks. If the woman, she was known to deliver before that, she was actually removed from this data set. So everybody had observable information through the 35 weeks of gestation, which is kind of one way to get around the variable length and the end of pregnancies. So here, what you can see is that there were the 5 trajectories here with women who started on, these are average fluoxetine equivalents, who started at a low dose and discontinued or reduced even further their exposure. We had a low sustaining group. We again see this group that came in around 40 fluoxetine equivalents, one that discontinued and one that sustained, and then this higher sustaining group. And what's interesting, when you look at these 12 weeks and then look at it out of the 35 weeks, there's not a lot of movement after the first 12 weeks. So essentially after the first trimester, the antidepressant use didn't change much, but there was a lot of change kind of in that initial first trimester of pregnancy. And one thing to note on something like this, with things like alcohol or other exposures that are all the same, you can just go ahead and model that. With something like this that are antidepressants across multiple different types of antidepressants and classes, you have to have a standard that you can map those all to. So here we converted these all to average daily fluoxetine equivalents. There are other, if there's no standard or you're doing kind of medications across things that can't be standardized, there are other ways people have done this with things like defined daily dose or things like that, but you do need to get all of your exposure into kind of one standard to be able to model it all together. And what I really wanted to highlight with this is that when we looked at our different outcomes, you see differences in kind of the pattern of the outcomes based upon the exposure trajectory. So here for cardiac malformations, again, this was only modeled through 12 weeks, but what we see is that the real kind of excess risk of cardiac malformations was happening in those 2 highest sustained trajectories. However, when we were interested in preterm birth, we see a pattern fairly similar to this, that if antidepressants in gestation were either very low or discontinued fairly early in pregnancy, they didn't confer an excess risk of preterm birth, whereas the sustained trajectories did have a slightly increased, modest, but increased risk. When we looked at neonatal respiratory distress, this is where it was really interesting. So here we found that even antidepressants that were discontinued early in pregnancy or that were maintained at very low doses still conferred a slight increased risk of neonatal respiratory distress. So it just kind of goes to show that based upon your outcome, the nuance in these trajectories may kind of confer different risk estimates that we probably wouldn't see if we were using, well, we certainly wouldn't see if we were using something like a binary exposure. And this can actually potentially shed insight into different sensitive periods based upon being able to compare the different trajectories against each other at different time points in gestation. So the last example I want to show is one with oral corticosteroids. And this is Dr. Palmsten's work. And what was really interesting about this is that the 2 exposures I've shown you before were kind of more of a chronic type exposure, whereas Dr. Palmsten wanted to apply these methods to oral corticosteroids. These are taken on a PRN basis or as needed. And so the question was, could you still fit these trajectories with something that has a much more kind of sporadic profile of use than something that tends to have kind of more smooth distribution. So in Dr. Palmsten's study, what you can see here from something like oral corticosteroids is that they really are taken differently by different women. All of, in this example here, all of these lines are a woman. The black dots are where there was no oral corticosteroid use. And so here you can see like someone used it, they stopped using it, they used it, they stopped using it, whereas others kind of used all the way across gestation. And so the question was whether these would work well in the trajectory methods. So here they've done the daily dose. And if you could see the tracings behind this, you would see that you have a lot of kind of up down here of people taking corticosteroids and not taking them and taking them and not taking them. And you see that in the confidence intervals around these trajectories. They then modeled this as a cumulative dose. So they kind of smoothed out that distribution by saying, by letting the exposure accumulate over gestation, if you stop taking it, you stay at that level. And then if you resume taking it, you go up. But it creates that more kind of smooth trajectory that you see here with a lot tighter confidence intervals around each trajectory group. And they were then able to actually look at both trajectories with their outcomes of interest, to determine kind of which ones better predicted the outcomes of interest in this study. So this is really just to kind of show that it is possible to model these with different types of exposure, with exposures that may be more intermittent or infrequent. You may just need to think about kind of the underlying functional form of how you're mapping your data before you run the trajectories. So to summarize, these trajectories can be applied to either the exposure or the outcome. I've shown you here examples with the exposure, but these can just as easily be applied to outcomes as well. They are applicable to acute or chronic events. You may just need to kind of think about that underlying kind of functional form of your variable prior to running the trajectory analysis. There are limitations. Dr. Palmsten mentioned things like the inability to adjust for time-varying confounding. So if that's a concern in your field of interest, then this may not be the method for you, and you may want to look at other types of methods that allow you for modeling time-varying confounding. There are sample size considerations. As we've mentioned, you have to kind of think through what's the smallest size you can have in each trajectory to be able to then do anything with it. Because at the end of the day, after you get people into their trajectories, it just becomes a variable of 0, 1, 2, 3, or whatever your trajectory assignments were, like any other kind of variable you would put into a model. So you have to think about the strata size for that, and what will be kind of analytically relevant in your analysis. However, we have found that these nicely incorporate time, dose intensity, and duration of exposure, and we found them to be quite useful in studies where it's important to be able to incorporate in all of those. So thank you very much for your attention, and I'm happy to answer any questions.
Thank you. So we do have a couple questions for you. So first one is, your example of the difference between the trajectory and normal approaches to measuring the amount of alcohol is fantastic. Do you think the trajectories capture more or different information than breaking the gestational window into time periods such as first, second, and third trimester?
Let me make sure I understand that question. So the question, was it specific to alcohol, or was this just in general?
This is us in terms of alcohol, but just in general, like
if the trajectories were more advantageous than looking within each trimester?
Yes, so having it split out as a trajectory instead of just looking at exposure in the first, second, and third trimester.
I personally think it was, again, the fact that we, especially with things like neurodevelopmental outcomes, we don't know if there's one trimester that's more or less important than the other trimesters. And so being able to kind of pull in and have that unique information contributing all into one variable, as opposed to having to look at first trimester, look at second trimester, look at third trimester, and then think through, do you want to model these independently, or do you want to kind of model it more as, letting each of them contribute into the outcome? To me, being able to see this all into one measure was more helpful. Again, because we don't know with many of these outcomes if, the second, third, or all trimesters, are more important than being able to kind of look at it all together.
Thank you. So next question was, do you have any recommendations for dealing with the subjective nature of case selection, and what criteria do you normally use?
Yeah, so that is probably the kind of biggest thing with KML. You know, what we did, for example, with the antidepressant trajectories, there you can look at it from 0 to however many trajectories, well, from I guess 2 to however many trajectories you want to look at. And with that, we ended up we had a big enough sample size that we could have continued to go up on trajectories. What was nice was that it also had clinical relevance. You had the trajectories sitting around 20 milligrams of fluoxetine equivalents, some around 40, some around 80, like doses that would make sense to clinicians and have and be able to translate better. And so some of it will just kind of fall back onto, does this have kind of clinical relevance, these trajectories? And then some of it will also be, again, do you start kind of getting these very, very thin trajectories where you can't do anything with them analytically? And then aside from that, you can rely on the criteria that KML gives you in the background. I can't say that I actually find those to be all that helpful, but you'll also see kind of, you need to plot out your confidence intervals and see how much heterogeneity there is within each trajectory. You can also run the analysis with different trajectory groupings and see, does that matter, based upon how I've classified their trajectories.
Thank you. So next question is, how should we use this type of time trajectories in thinking about designing life course intervention studies?
Wow, that's a really good question. So life course intervention studies. I guess I would maybe need a little more information on that. I mean, you can use, I guess for example, if you mapped an outcome over time in the trajectories, you could already kind of see potentially different points when you have inflection in the trajectories. Say you're mapping adolescent smoking through adulthood smoking over time. And so maybe you could see there when uptake tends to happen or when people tend to stop smoking anyway. Maybe that would kind of point to time periods you could exploit for intervention. Other than that, I think I would probably need to understand a little bit more about the question, but I think if nothing else, it would kind of show you the natural patterns that are already happening longitudinally in a population of interest.
Yeah, and I think also thinking about how many measurements, it could help you think through how many measurements you want to take of an outcome, for example. And if you were planning to run a trajectory analysis as an outcome, then just taking time points might not necessarily give you very detailed trajectories. Taking 1,000 time points, something higher order might be too much. So you can sort of think through like what are you hoping to get out of the trajectories, and how many measurements would you need to take in order for that to get that what you're looking for.
Perfect, thank you. And we have time for one last question. So what would you do if exposures may be associated with right censoring, for example, if a medication is also associated with loss?
Yeah, so if that's actually a really good question. And something we think about, in perinatal epidemiology a lot. That would be where it really depends on, can you stop this at a time point before you would end up with censoring? If you can't, something like, Cox proportional hazard models that are taking into account right censoring may be a better fit for your data. As I say, we've tended to kind of get around this either by stopping prior to when delivery could occur. But for things that you may have a strong association between your exposure and right censoring, as I say, the trajectories may not be the best approach. Dr. Palmsten, I don't know if you have any other thoughts on that.
No, I don't have anything else to add. I do just want to mention another question real quick, that when would you choose longitudinal K-means over group-based trajectory modeling? And my thought about that is that K-means is non-parametric, and some of the results can look kind of bumpy and wiggly, and the trajectory group-based trajectory results tend to be more smooth because it's using a polynomial function. So you can think sort of what fits your data better, and maybe what are you hoping readers to see.
And I do, sorry, I want to circle back because actually on the last question about right censoring, Dr. Palmsten actually has some really nice work where she was worried about right censoring. And so what they actually did was they ran trajectories of oral corticosteroids only through 20 weeks of gestation. And then they looked the second 20 weeks of gestation, they actually summarized oral corticosteroids in Cox proportional hazard models. And then we're able to kind of look at early exposure and late exposure, but using that different modeling approach in the second part of pregnancy, specifically to account for right censoring. So there are different ways that you can also kind of combine different methods together, which may make sense for the individual project.
All right. Well, I want to thank you both for an absolutely fantastic webinar. You did a great job explaining that, and I think I'll speak for everyone that we learned a lot from the trajectory modeling that you explained. So I would just like to wrap things up. Again, this is the last webinar, so I would really like to thank the executive committee. Sherry Barkin and Frederick Haskell have been helping me plan this the entire time, and it has definitely been a team approach. So thank you so much for all of your input and hard work in helping us get this planned. Dr. Jomi Ramsey is on the call as well, and she has been doing all of the Q&A and helping keep everything in order. So I'd really like to thank her for her time. And then also for funding from Utah CTSA and Vanderbilt CTSA to help us cut the videos and make them viewable. And then we've also received funding from the Life Course Intervention Research Network, which again allowed us to take the webinars and make them into something that can be used in the future for coursework. So thank you very much to all of the people who have contributed to this webinar series. Also, there were some questions about, can we see these webinars later? And the answer is absolutely. Jomi has placed a link to the YouTube channel for the webinar series in the chat box, and we have the full webinars placed in the YouTube. We're editing them a little bit, so they're placed in there as soon as the editing has been completed. And then we're also cutting the full webinars into smaller chunks of information that can be used as asynchronous learning tools, so that you can really pick and pull from the parts that you want to learn from. So if you want to learn a little more about agent-based modeling, you can watch that video. If you really want to dig into the trajectory modeling a little bit more, you can pick out those videos. So those shorter video segments will be released in early January of next year, and we will send out many emails advertising them, and we hope that you can use them in the future and use them for your coursework as well. So again, thank you very much to everybody who has helped with the series, and to our speakers today for a wonderful job. And we'll see y'all later.